In this video, we're going to take a look at how to do exponential regression using the TI-84 calculator. So let's start with some data. This data shows the U.S. oil production from the year 2008 to the year 2023, where we've labeled our input values as X as the years since 2008. So 0 is going to stand for 2008, 1 stands for 2009, and so on and so forth. And then along with that, we have the production in millions of barrels of oil per day in the US. So in 2008, there was about 6.78 million barrels of oil produced per day in the year 2008. By the way, this data comes from the US Department of Energy and can be found at this website. And just a plug for that website, obviously I have it pulled up. They have lots of years, not just 2008 to 2023, but they have a lot of different information going back, it looks like all the way to 1949. But we're using 2008 to 2023. Now we're going to use the TI-84 calculator to do that. I'll show you this in a really quick way because I've already plugged in the data. But the first thing we need to do is plug in our data. So we go to Stats and then Edit. So I just hit Enter there. And then in List 1, I'm going to use years since 2008. As you can see, I already have those plugged in from 0 all the way down to 15. And then in list 2, I'm going to put the production of oil in terms of millions of barrels per day produced. And again, I have all those corresponding values plugged in list 2. Then I will go back to the home screen by hitting second and then quit. And now we're ready to do our exponential regression. So what I'm going to do is I'm going to take this TI-84 and hit Stats, Calculate. In this menu, there's lots of different types of regression. There's linear regression, there's quadratic, there's cubic. And if I scroll all the way down to number 0 there's exponential regression. Exponential regression asks for a list for your X values and a list for your Y values. You're going to put L1 and L2 into those two lists. If you want to type L1, remember that's the second key and then the number 1. If you want to hit L2, that's the second key and the number 2. So we have that. I don't think we need to store a frequency list. And then we'll just calculate. There's no frequency list here. We don't need to store our regression equation. Let's just calculate that. And this gives me the exponential model. This says the exponential model for this data set is y equals a times b to the power x, where a is 6.88 roughly, and b is 1.075566, et cetera, et cetera. It also gives me the correlation coefficient. By the way, this is not Pearson. Pearson is linear correlation coefficient. And it gives me the R squared that tells me how well my data fits. By the way, if you don't see the R and the R squared, that means your diagnostics are turned off. If you want to turn your diagnostics on, the easiest way to do that is to hit second and go into the catalog and then scroll all of the way down till it says diagnostics on and then hit enter. And then hit enter again. You'll hit enter twice. So if you do not see the R or the R squared, make sure your diagnostics are turned on. You hit enter once, it'll say diagnostics on, and then done. And now we can go back to our exponential regression, just like I did. If you do want to store that regression equation into your calculator, you can store it in the using the variable key. So you go variables, and then the y variables usually is how you want to store that with y1. That'll store it in the y equals menu as that equation. So that's the exponential regression equation. So again, here's our data. The exponential regression equation, if I wrote that out, I'll round things to 2 decimal places, would be 6.88 multiplied times 1.08, if I round it to 2 decimal places, raised to the x power. Now you'll notice that also, as far as the correlation coefficient goes, we were given both the R, which I'll round to 4 decimal places, that's traditional, 0.9822, along with the R squared. Sometimes people will capitalize that, which is 0.9647. And that R value and that R squared are pretty close to 1. So that means the regression equation is a pretty good fit to this data. By the way, in other scenarios, in other technology like Excel, you're given the equation as A times the irrational number E raised to some power K times X. And if you wanted to do this, just realize that E to the K is actually your 1.08. So if you wanted to figure out how to write it as an exponential equation with base E, all you have to realize is that that K is going to be the natural log of this 1.08. And technically, you probably should use not the rounded version, but the actual version 1.0755667769 that was. And in this case, if you wanted to use base E, then you'd have to raise it to that K power. And by the way, that K comes out being about 0.0728. So if you want to write it as base E, you just take the natural log of this value, and you can have that as your coefficient of X in the exponent of E. Hopefully that makes sense. Again, this is what the calculator gives. If you want to rewrite it in base E, you can do some simple algebra. But there you go. That gives you your exponential regression equation, your correlation coefficient, the R squared, for any data that we would have, as long as we have X values and Y values. One other thing that I wanted to mention, along with the exponential regression equation, you can see I typed in here, is that when we did our calculations, we stored that regression equation with Y1. So now that regression equation is stored with y1. If you wanted to, you could graph this out by making sure you turn on a scatter plot with your X list is L1, your Y list is L2, and then whatever marks you want to use. I'll use these box marks. And now if you hit zoom stat, which is zoom number 9, then it'll plot out a scatter plot for all your data points. And because we stored in Y1 the regression equation, when we look at the graph, it'll show the fit of that equation to the given data in a scatter plot. So you can also do that as well. Again, that's just making sure your stat plot is turned on with a scatter plot. X list is L1, Y list is L2. And then you get that. So you can see that exponential regression equation plotted along with the data in your calculator. Based on that prediction, using X values that are years since 2008 and Y values that are production in millions of barrels per day in that year, during that year, you can do lots of other things with that exponential regression equation as well. So that's how to deal with exponential regression on the TI-84 calculator.